Hi, Chris Guzmal here. Last time we implemented the extractDigit method as a helper method that will support our implementation of a radix sort. This time we're going to implement a radix sort helpers test, which actually I've already implemented, so I'm going to talk you through it, and I apologize for those of you who would like to follow along character for character, but what happened was I wrote this, then I had internet connectivity issues, and so my fumblings and failings were particularly irrelevant to most viewers. So I have restarted, but I didn't want to just delete and rewrite this code. I wanted to take advantage of it. We'll see whether or not that actually is a benefit to you. I hope it doesn't hurt. So we have a radix sort helpers test, which is public static void, and we have inputs of satellite data. We've done satellite data sorts before. Our satellite data here is a sequence of values which are 2 digits long. They don't have to be 2 digits. They don't have to all be 2 digits. But this is a simple test, and that's what we have right now. We wanted satellite data that had more than 1 digit, and the simplest thing I could come up with was something that had, well, 2 digits. The data that we're going to sort the satellite data on is in AR, and we've just extracted the first digit of each element of the satellite data, which is exactly what we would expect the extractDigit method to produce, and our test code that we've written already has confirmed that would work. But here we're nevertheless simply assuming that the extractDigit method has been successfully applied to extract the least significant digit from SAT and put it into AR. So all we're doing is we're seeing whether or not, having done that particular extraction, we can do a counting sort with satellite data that is an integer, and we have a method called counting sort with satInt that we've already implemented and tested, and it takes AR and SAT, and the expected result would be 31412412 sorted by the last digit, which would just swap these last two values. 24 and 12 would get swapped, so our expected result would be 31411224. And then the usual set of code, which someday we will encapsulate, that compares the expected to the actual value and increments pass when we have success and fail otherwise. So, plus it prints things out when it fails. Now then, when we compile this, it does compile successfully. The question is whether radix sort helpers test 1 actually runs without error and indeed passes. So let's copy the definition of the signature and paste it into our sequence of tests in main. And don't forget our semicolon at the end of that line. And now all that I want to do is restore my window from which I can do my compilations and runs. I click run, and we pass 10 and failed 0. So that particular test succeeds, but now we're going to go ahead and see whether or not we can do the radix sort more fully with a radix sort helpers test 2, I guess we'll call it. And this time we're going to try and make it so that we go from start to finish on our radix sort. So I've modified it. I'm going to zoom in here again. Oops, I've maximized the wrong window. That's okay. I knew what I was doing before. I just wouldn't believe myself. All right, so radix sort helpers test 2. It's going to start, we want to start with our satellite data here, but our extracted information, AR, is going to be equal, instead of to 1142, well, that's what we think it is. All right, so we'll comment that out. And instead, we're going to invoke the extractDigit method, okay? And we're going to extract a digit from SAT and digit number D. Okay, that's what I was thinking I was going to do. SAT D. But this is going to be incorrect, and it's a nice little exercise in data type recognition, as it were. So let's see what happens when I restore this and run this. Because all I did was make it so that I invoke the extractDigit test, but the problem is it complains that it cannot find, well, it can't find the symbol D. Well, yes, that's an issue. Certainly true, so we'll replace D with 0, the 0th digit. But now when we run, I'm expecting an error, and I get it, and it says int open square bracket, close square bracket, cannot be converted to int. And that's because extractDigit extracts the digit of a single variable rather than every variable inside of an array. And so while our intuition was right, and goodness knows Python might make it just work, here in Java we have to have an explicit method that deals with the first argument being an array of integers. Well, that's not so hard, one would think anyway. So I can just write another extractDigit method, okay, and do some overloading. What I'm going to return is an array of integers instead of an array. Excuse me, instead of an integer. What I'm going to take is an array of integers, n, okay, which I'll call an, just to kind of vaguely nod towards it being correct. And now I don't return this. I have a retval, which is equal to a new array of integers of size an.length. Okay. And now my mission is to return retval. And my indenting again is problematic. Look at this. It's just like, come on, people. I don't know why. Someday I'll get this figured out. But here, I can't. I obviously don't want to return here. I need basically for retval at some location, which I will call I, to be equal to something that resembles the thing here on the right-hand side. But of course, this retval of I we have to have I established, and so we need our loop, a canonical loop, or canonical idiom for int I equals 0, I less than retval, we'll call it dot length I++. So this is just our standard idiom of iteration in Java, C, C++, and a few other languages, no doubt. So I've built a for loop around this assignment of retval of I equals. This thing on the right-hand side is not exactly what I would have wanted. I have good news, though, because I don't even have to call that. Notice how the editor automatically highlighted code that is identical to what I have. Let's do a little bit of encapsulation, because guess what? I can extractDigit. This is so confusing and exciting. ExtractDigit of the particular value, which is going to be an of I at location D. Okay. And so the extractDigit invoked on line 41 is not the extractDigit I'm defining on line 38. It's the extractDigit I'm defining on line 34. This is sort of a pseudo recursive invocation of extractDigit. It's just an invocation of extractDigit, but with the specific type. You would think there'd be some kind of pattern that would allow me to kind of automagically just create this code on from line 38 to line 44. I imagine perhaps an AI would do it. The question really now is, does this code actually compile and run? So once again, let us go. Let us attempt to restore. See, that's not the restore. There's the restore, the little dots over here. See, the 3 dots up here look a lot like the 3 dots here, so you'd think that was it, but it's not. That's where I can do my restore. And now if I run, I'm hoping I won't get the same compiler errors before. I don't get any errors at all. Did my extractDigit method work? I don't remember whether the extractDigit test that I'm interested in now is actually being invoked. I'm doing extractDigit test 1, but what about Radix sort helpers 1? What about Radix sort helpers test 2? That's the one that I'm thinking I haven't done yet. I don't. I have Radix sort helpers test 1 here. You know, if I had a good version control system, I could more readily detect whether or not I had invoked Radix sort helpers test 2. So now I invoke Radix sort helpers test 2 as well, hoping to see 11 passes and 0 fails, and I do. So the good news is now Radix sort helpers test 2, shown right here, does indeed extract every digit of the array SAT at location 0 and successfully does my sort. Let's press on. Since we've gone past the 10th minute, let's push it right up to possibly as many as 20 minutes. Let's go ahead and do Radix sort helpers test 3. This is going to hopefully be a more full Radix sort test, Radix sort helpers test. So everything is the same as Radix sort helper test 2, but now we're going to extract the next digit and do the next sort. So AR now becomes extractDigit of SAT. Is it SAT? Or it's an interesting question. It's not extractDigit of SAT anymore. We have sorted into actual, so SAT is no longer what we sort on. It's actual because that's the partially sorted original sequence. And so actual then is presumably 3141 1224 until we do the extract digit. Now we want to extract digit number 1 from actual and get that into AR. And is that what I really want to do? Yeah, I think it is. And now I'm going to do actual is going to be counting sort with sat int. And the input data is actual instead of SAT. I'm not sure I'm thrilled with that because I'm taking actual in and putting actual out. That shouldn't be a problem, but it certainly is going to produce my actual value. And my expected result is no longer 31, 41, 12, 24. We are expecting it to sort these in order fully. So the first value will be 12, 1, 2, and then the next one will be 24, and then it'll be 31 and then 41. And that is increasing in order. So let's see whether or not that compiles and runs. Well, compiles anyway. It compiles. Radix sort helpers test 3 is not invoked. So now let us invoke it and see whether or not it thinks everything's copacetic. Copacetic doesn't really tell you anything, does it? But it passed the test. So I'm truly excited to report that the Radix sort helpers test 3 does virtually everything we want for a Radix sort, except that we're going to have to now generalize this code. This code does indeed do a Radix sort of the data located in SAT, and we really do verify that by comparing the expected to the actual value that's sorted. However, we have not written the general code, so for the actual Radix sort. So next time we will write, hopefully, the actual Radix sort that is a generalization of the code on lines 81 through 85 here.